I was sitting in my basement bored and reading my water bottle. On the back it read purified by reverse osmosis. I started to wonder what osmosis was in the first place, so I looked it up. The Google definition was the net movement of water over a semi-permeable membrane from an area of higher water concentration to an area of lower water concentration. I didn't know what any of that was, so I researched further. I learned that the semi-permeable membrane is like a little wall with tiny holes so that water molecules can fit in, but larger molecules like salt cannot. It took me days just to write notes. When I had enough information, I made a presentation, took it to school, and showed my enrichment teacher. This started the idea for the whole film project.
What is osmosis? Let's pretend that we have our semi-permeable membrane. We need to have two jars pictured in our heads. Now put them together, connecting the tops. In the middle, instead of lids, we put our membranes right there and throw away those lids. Now, put water in both jars with something like salt molecules inside one and purified water in the other.
The membrane only lets water molecules through. The water molecules gradually go through the membrane, diluting the amount of salt-sized molecules on the other side. Finally, the water on the salty side is now higher.
To understand osmosis better, picture a U-tube with pure water on both sides and a semi-permeable membrane in the middle.
If we add salt molecules, which are too big to go through the semi-permeable membrane on the left side, the water will gradually rise, trying to make the water-to-salt ratio even. The overall effect is that the water on the left side of the U-tube has risen. A hypertonic solution has higher concentration of salt-sized molecules. An isotonic solution has an equal concentration of salt-sized molecules, and a hypotonic solution has lower concentration of salt-sized molecules. In osmosis, water moves from a hypotonic side to the hypertonic side.
Gummy bear experiment. We did an experiment with gummy bears to see what osmosis looks like in hypertonic, hypotonic, and isotonic solutions. Hypotheses. 1. If we put a gummy bear in a hypertonic solution, it'll get bigger and weigh less. 2. If we put a gummy bear in a hypotonic solution, it'll be almost exactly the same and weigh more. 3. If we put a gummy bear in an isotonic solution, it will be exactly the same size and weigh almost exactly the same. Procedure. Materials. 4 jars, 4 tablespoons of salt, water, enough to fill all 4 jars gummy bears. The first thing we did was get 4 jars. Fill one with water and half a tablespoon of salt, one with water and 1.5 tablespoons of salt, and the last one with water and 2 tablespoons of salt. Then we put a gummy bear in each jar and waited 18 hours and 45 minutes. Data and observations. The original weight of the gummy bear was 2 grams. The original length was 2.2 centimeters. When we weighed and measured the gummy bears after they soaked overnight, most of them had changed weight and length. Analysis. The gummy bear experiment taught us that when something is put in a hypotonic solution, it gets bigger because the water moves into it. When it's put in a hypertonic solution, it gets smaller because the water moves out of it. They helped us understand osmosis by giving us a physical representation, allowing us to see osmosis in action.
Osmosis in the real world.
Reverse osmosis is when you force water through a semi-permeable membrane. The clean water goes through, the unwanted materials stay inside the filter.
To explain reverse osmosis, we have to remember our previous setup, with salt molecules on the left of the U-tube, pure water on the right, and a semi-permeable membrane dividing them. If we apply pressure on the left, pushing the water molecules through the semi-permeable membrane but trapping the salt molecules, we'll get all pure water on the right, ready for drinking.
Examples in the real world. Water purification is basically reverse osmosis. Reverse osmosis is when you push the unwanted things through a filter and out of the water. Reverse osmosis in maple syrup. Maple syrup is a yummy thing to put in your pancakes, waffles, or French toast. but it is not an easy process. It takes 44 gallons of sap to make 1 gallon of maple syrup. Using reverse osmosis to take some of the water out before boiling the sap can make the process easier.
Desalination is taking salt water and making fresh water. Reverse osmosis is an efficient way to do this. It is important because many people die or get sick if they did not have fresh water. Ways living things use osmosis. Watering plants. The roots soak up water through osmosis. Showers and baths. Your skin soaks up the water and becomes wrinkly.
From this project, we have learned that osmosis is important because it helps us make fresh, purified water, and it contributes to how all living things operate. In conclusion, we thank Quinn for reading the back of her water bottle and taking us on this learning journey through osmosis.